My dear friends, welcome to Rajashekhar classes on Applied Data Science with Python. This is lecture number 642. In this lecture, I will continue my discussion on recurrent neural networks. This is a slide from my previous lecture. I request you to recall this particular slide. Before understanding this particular lecture, please go through my previous lecture. Just see. This we discussed O3 equal to f of w x13 plus w dash O2, isn't it? This one we discussed. It's keep happening till the time we reach t equal to 5, as we have 5 words. Just try to recall, in our first review we have five words: x11, x12, x13, x14, x15. Therefore, we are repeating this till t equal 5. I reach my 5th word. Let's assume I am at 5th word. The structure is like this. What is my O5? O5 equal to f of w of x15 plus w dash of O4. So, you finished all of your 5 words. You finished first word, second word, third word, fourth word and 5th word, isn't it? Now, your goal is to generate y1 because your sentence is over. Your sequence of words, first you send the first word, second word, third word, fourth word and 5th word. You have got output, isn't it? Output for 5th word, isn't it? You have got output for 5th word. You don't have anything more. You have reached the end of the sentence. Now you have to generate your y1. How do you generate your y1? It's very simple hack. You take the output of 5th layer, take your O5. What is my y1? My y1 is binary, isn't it? What is my y1? Y1 is binary. So it's basically a classification problem. So I just put a softmax layer, or I can say logistic layer here. This is a 2-class classification problem. This softmax layer or logistic layer generates my yi tilde. If it is x1, it will generate y1 tilde. What is the size of O5? Your O5 is 100 dimensional vector. Your w double dash is 100 by 1 dimensional vector, because your O5 is 100 dimensional vector, and you have one sigmoid neuron. Just see your soft sigmoid neuron, because your output is 2-class classification problem. I will just say this O5 is, as we discussed, f of w x15 plus w dash O4, isn't it? I will connect everything and draw this. Just see here. Just I am redrawing things. What is my O1? O1 is f of w x11. Your O1 depends on first word x11. Your O2 is what is your O2? F of w x12 plus w dash O1. What does it mean? O2 depends on the second word and output from the first word. O2 equal to f of w x12 plus w dash O1. Similarly, so on so forth, your final class label, your yi tilde depends on final output, isn't it? Your yi tilde depends on your final output, that is O5, along with your learning weights, isn't it? So you have 3 types of weights here. You have W, just see, you have 3 types of weights. You have W's, which are weights connected to the inputs to your hidden layer. W dash, which is connecting your output from the previous layer to the input to the next layer. You have W double dash. Just see this W double dash. This is 3rd type of weight, I can say, which is the weight connected to the final output through a softmax and get your yi tilde. Let's actually draw this to much more easy to understand. You have just, I am writing, you have your x11 here, and it generates just see, it generates O1, and next you send x12, you have your function f which generates O2, isn't it? Next you send your x13, same function which generates O3, isn't it? It generates O3, and x14 which generates O4, isn't it? You have your x15 also, isn't it? And I can say you have x15, this generates O5. Your this I you can write here, this must be O5, isn't it? Now I will take it input to softmax layer. On top of it, from here I will generate yi tilde. These are the types of diagrams that you have see a lot in this diagram. This is your, what is this? You can see the time axis here. What is this one? This one is actually, this is time axis. This we already discussed this one many times. This is time axis. You have just see how w's, you have w's here, you have same w because this is the weight that connects input vector to your F matrices, to your activation units. Now you have weights W dash, isn't it? W dash connecting the output from the previous layer as the input to the next layer, and you have your W double dash also. Actually here, if you speak strictly, here you have W double dash, isn't it, which is connecting to a final, output to the class label. Look at this. The whole thing is just, if you observe carefully, this whole thing is just repeating structure. If you see the structure is repeating again and again. You might wonder, this does not have the input, isn't it? Let's add this input here. Let's call this as O0. Let me call this as O0, isn't it? Let's have weight matrix W dash. O0 means what? Output of zeros, I can say. Let's have weight matrix W dash here also. X, just see, let me keep here also same thing, same. I'm keeping same W dash, isn't it? Just I'm keeping W dash here, except that O0 is basically set of zeros, isn't it? What is your O0? It is set of zeros or random numbers or Gaussian random numbers, because there is no zeroth word, isn't it? My W dash, W double dash are all initialized. W dash, W double dash are all initialized based on based on what the activation unit is. If this activation unit is tan H or sigmoidal, we already know that Xavier or Glorot type of initialization. We discussed this one. Just try to recall, in our previous lectures we discussed about these initializations. If these are ReLU, we know that we have to use Hay initialization. Very simple concept, because the structure is repeating. This is called a recurrent or repeating neural networks, because recurrent basically means repeating. This is what happened in this is Hay initialization, isn't it? If the activation function is ReLU, then use Hay initialization. If this activation unit is tan H or sigmoid, then use Xavier or Glorot initialization, isn't it? This is what happened for x1, isn't it? Yes, this is x1 means x11, x12, x13, x14, x15, isn't it? You have x2, for x2 you have corresponding y2 also. What is x2? x21, x22, x23. You have the same structure. Just see, same, you can imitate the same structure. We have the same set of neurons. Now you input, which one you will input? You will input x21, isn't it? The structure does not change. We have the same set of neurons. Now you input x21, whatever the weights that are trained at the end of x1, isn't it? Whatever the weights that you have at x15. What is your x15? x15 is the last word of the first review. That weights your keeping that weights, whatever after back propagation and everything, we will simply reuse the weights that we had at last word of the first review, that is x15, isn't it? Again it generates what it generates O1, isn't it? But this O1 is generated using first word of second sentence, that is x21, and this O0 is anyway is a random variable. Now you repeat this, it generates O2, isn't it? It generates O2. Now you give input x23, which generates your O3, isn't it? Since you reach end of the sentence, now you have your softmax layer which generates your y2 tilde, isn't it? And you have w dash and w double dash. This is actually this is time axis, isn't it? In your first sentence, since you have 5 words, you did it, since it has 5 in first sentence or first review, since you have 5 words, you did it for 5 time steps. The second one you have only three steps and you generate output, isn't it? So the actual neuron, each of these individual neurons activation, just say this is actual neuron, your input from the OT minus 1, you can see you have input from the previous W dash, actually if you see your activation functions F, same input, some input from the previous layer, that is OT minus 1, and W dash and W are here, isn't it? This XIT, is input. This is what is your XIT? This is the teeth word. I can say XIT is teeth word in ith sentence. It generates OT, isn't it? If XIT is the last word, what you have to do? If the last word means, if XIT is the last word, if it is the last word, then just you take this OT. What you have to do? Just you take this OT and connect it to a softmax and generate YT cap, isn't it? This is core structure. So there is other way of representing, there is box way of representing the layer in a recurrent neural network. One way of visualizing recurrent neural networks is this one layer after the other layer, but you should always remember that where the weights are there are weights here, you have weights W dash and W double dash. If you forget where the weights are, you will mess up the whole back propagation concept, isn't it? You will mess up with the whole back propagation concept if you are not taking care of weights. It take a little while to get used to it, isn't it? Slightly different from convolutional neural networks and NLPs, isn't it? There is also other nice way of representing it. The way of representing is, if you think of your recurrent neural networks as a box, it has 2 inputs. It has OT minus 1 from previous layer and you have XIT. Just see this particular diagram. So this is the so on this there is a weight W dash, on this there is a weight W. So you know these weights we have seen. You know that dot product between OT minus 1 and W dash. There is a dot product between OT minus 1 and W dash, and XIT is multiplied by W. Just see these two things. You have to multiply dot product, and you have to take dot product between these two, and again dot product between these two, isn't it? The first thing that you will perform here is summation operation, isn't it? This plus means what? You have to make use of summation operation. You are taking W multiplied by XIT. What you are doing here, your this W is multiplied by XIT, and you have W dash is multiplied by OT minus 1, and you have here, what is that? W into XIT. Just see, just if you observe this one, what's happening? This is W into XIT, this is W dash into OT minus 1. Just you are summing up, because there is summing symbol. There is some symbol means what you have to do here, just you are summing up, nothing more than this. So you compute dot product of both of them and then sum it up. After you sum it up, you send it to the activation function f, your activation function f. What you get here is, it is basic activation function, what you get here is basically a vector. You are sending it to activation unit. This activation unit is generally generating, this activation unit is generating OT. Now your output, OT means your output at t, but you are also taking from this, because your XIT could be the last word. That's important. If your XIT could be the last word, may or may not be. If it is not last word, you don't have to worry. If it is the last word here, you have other function here. This function, what is other function? The other function is G, which generates your yi cap, isn't it? In our case, G is basically softmax or logistic unit, softmax or logistic unit, the sigmoid unit. So typically what people do often is, when they write this, they often represent this in short like this, the loop sort of things. I have XIT, just see, I have XIT here, just I am keeping loop sort of thing here. Just if you observe this one, just you see here, I have XIT, I have OT minus 1, I have yi cap, and I will put a loop here. Just see, I am putting a loop here. Actually they don't even write this. Actually they don't even write this particular thing. Which one? They don't even bother this particular one, isn't it? To say this layer, why we are keeping this one? To say this loop indicates that this is recurrent layer. I have XIT here. This loop represent, it's a recurrent layer, and this loop open up over time. Remember, this is, what is this? This is time axis. This loop, this is time axis. This loop open up over time. Remember, this is on x-axis. I have time axis, isn't it? First I will send x1, x1, x11, x12, x13, so on so forth, x15. One thing that people get confused, this is the one thing people get confused a lot. These are not multiple layers. One must understand. Just this is time axis, isn't it? These are not multiple layers. This is one layer of this. This is not multiple layers. If you speak strictly, this is not, entire thing is not multiple layers. These are not multiple layers. This is one layer of neural networks, but at different times. Just we are opening the loop. Just see this one. Just see this loop structure. This loop we are opening, but just see here you are opening the loop. Here you are opening the loop. At the end of the day, you are connecting to softmax through some weights and generating yi cap, isn't it? These are not multiple layers. These are not multiple layers. This is important. These are not multiple layers. Multiple layers, isn't it? This is one layer of neural network, but at different times. Just go through this. If you have any difficulty, please keep a comment. Thank you very much.